So in this video lecture, we will be solving certain numericals. So this is the first numerical of our acceleration, where we will be drawing the displacement time, velocity time, and acceleration time graphs. So what is given to us is the position of the particle, which is defined as 2 sine pi by phi t plus 4. This is the displacement. So I'll say this is s. To get the velocity, we'll have to differentiate this with respect to time. So it will be ds by dt. ds by dt will be equals to the velocity, which is 2 cos pi by phi t into pi by phi, right? The derivative of the argument. So this the angle is actually the entire thing, pi by phi into t. Then we have, if we differentiate this again with respect to time, we will get the acceleration. So dv by dt will give you the acceleration, which is equal to 2 sine negative 2 sine pi by phi t into pi by phi the whole square. Okay. So this is your acceleration. Now we need to plot this with respect to time. The time interval given is 0 to 10 seconds. You can appropriately select. Now we will be drawing a table from which it becomes much more easier for us to draw the graph. So let us see, time is one of the columns. Displacement we have, velocity and acceleration. Time is ranging from 0 to 10. It means that it will start from 0, and then you can have suitable intervals. You can either have an interval of 1 second, so it will be 0, 1, 2, 3, 4, 5, or the more lesser the interval, better would be the graph form. However, I will keep here the interval of 2.5 seconds. So 0, 2.5, 5, 7.5 and 10. Okay, so these are the times for which we will be finding our displacement, velocity and acceleration. You just have to substitute this time in these equations. You will get the required quantities. Now the easier way to do this is in our calculator using the table function. The scientific calculators that we have, generally 991 ES and all, in that we have a function called as table. If we go in that table function, we can type these equations there. So if I type 2 sine pi by phi x in the table function, now this pi by phi t is actually radians, and our calculators are by default they are in degree modes. So we'll have to convert these radians into degrees. So we'll have to multiply by 180 by pi. Okay, so this becomes your displacement equation. Now x has to range from 0 to 10. So when you press equal to, you will be asked that from where the x starts. So x will start from 0 and x will end on 10, and then the step it will ask, we have to give us 2.5. So you will directly get all the answers. So we get displacement as 0, 2, 0, minus 2 and 0, right? This can be further refined if the interval of time is lesser. Some newer calculators also have the function of putting g of x equals to, this is f of x and this is g of x. So in some latest versions of the calculator, you can do you can do displacement and velocity simultaneously in the table function. Similarly, when we put about the velocity, we just do cos pi by phi x into 180 by pi into pi by phi, starting from 0, ending on 10 and step of 2.5. We'll get the answer as 1.2566 at time equals to 0, then 0, then minus 1.2566, 0 and 1.2566. Similarly, for acceleration, we can put minus 2 sine pi by phi x into pi by 5 the whole square. We'll get the acceleration as 0 minus 0.021 minus 0.043 minus 0.064. Okay, I think so you will get acceleration as 0 minus 0.789, 0 plus 0.789 and 0. Finally, we can plot these values on the graphs. So let us plot them. So the time interval is 0, 2.5, 5, 7.5 and 10. Displacement time graph will be, since it's a sine curve, we can predict it how it is going to look on the graph. It is a sinusoidal curve and it has an intercept of 4, so it will be starting from y equals to 4. So here, yeah, we have to actually add 4. I guess in that equation that 4 was not added, so this will become 6 and this will become minus, this will become 2. When minus 2 plus 4 is actually 2. So it is 0, 6, 0 to 0, because this 4 was not there in that equation. So 2, 4, 6, 8. And yeah, of course, the 4 has to be added to all of them. So these values will be 4, 4, 2, 4. Okay, so this 4 is actually forming a baseline for that sine curve, and from this the sine curve will be formed. At 2.5 we are getting 6, then at 5 we are getting 4, at 7.5 we are getting 2, and at 10 again 4. So this is the displacement time graph. Then the velocity is, it is starting from 1.2566 and the minimum value is minus 1.2566. So 0, 2.55, 7.5, 10. We can see that it is even going negative. So let us say that the highest value only I will plot here, which is 1.2566. At 2.5 it is becoming 0. At 7.5 it is becoming 0. Rest all other values it is maxima and minima. Okay, so this is how the velocity curve is going to look. And then acceleration curve. 0, 2.5, 5, 7.5 and 10. So acceleration curve is 0 at 0, 5 and 10, and its maximum and minimum is 0.789. So again this has a minimum 0.789 and minus 0.789. So this is like this. This is your acceleration curve. It is same like the displacement time curve. It is also sinusoidal, right? So this completes your first numerical. Let us move to the next numerical. So in this next numerical, we have to construct the AS graph given as a VS graph. So velocity is described as a function of S. We know that A is equal to V into dV by ds, right? So using this formula, we can actually differentiate the velocity with respect to the displacement, because in the graph it is given as a function of displacement. So we'll use this and we'll again tabulate our results. So it is better to plot the graph. At S, we know the first column will be S, then the second column is V, third is dV by ds, and fourth one will be acceleration, which is V dV by ds. So from 0 to 3, our velocity is 2s plus 4, dV by ds is 2, so acceleration is V dV by ds, which is 4s plus 8. At s equals to 0, our acceleration is 8 meters per second square, and at s equals to 3, our acceleration is 20 meters per second square. Okay, this is for the interval of 0 to 3. Then we move to 3 to 6 interval. There the velocity is given as s plus 7. The derivative of this with respect to displacement is 1. So acceleration will be also equals to s plus 7. At s equals to 3, we have acceleration is 10, and at s equals to 6, we have acceleration as 13. So that's it. These are the values that we need to plot on the graph. Let us plot the graph here. So this is the acceleration displacement graph from 0, 3 and 6. At 0, we have acceleration as 8. So let me just plot here 4, 8, or rather I'll choose a different scale, 5, 10, 15 and 20. So at 0 we have 8, at 3 we have 20, it has to be joined by a straight line. Then in the second interval at 3 it drops down to 10, and then at 6 again it rises to 13. Okay, so this is 8, 20, 10 and 13. This is your acceleration displacement graph. Next question. So what is given in this question is that a motorcyclist is traveling at speed of 60 feet per second. So this is the motorcycle. The initial speed of this is 60 feet per second, and he wishes to pass the truck which is traveling at a constant speed of 60 feet per second. So there is a truck which is ahead of the motorcycle, and again it is traveling at a constant speed of 60 feet per second. The motorcyclist is accelerating at a speed at an acceleration of 6 feet per second square, and the maximum speed that it reaches is 85 feet per second square per second. The truck is not accelerating, the truck is going at a constant speed, so his acceleration is 0 basically. What we'll do is that we will try to see what is the location of the motorcycle in comparison with the truck when it reaches at this speed, when it reaches the speed of 85 feet per second. So first of all, we'll have to understand how much time is required for the bike to reach to this 85 feet per second. That we can find using the formula v minus u by t is acceleration. So t we can find from this. It is 85 minus 60 upon 6, which is 25 by 6 seconds. So in this 25 by 6 seconds, how much distance has the truck travelled? The truck has travelled the distance of 60 into 25 by 6, which would be 250 feet. So when the bike reaches the velocity of 85 feet per second, the truck has already travelled 250 feet. Let us try to see it in the diagram, how and where the bike will be in relation with the truck. So if this is the position of the bike initially, where the speed it had was 60 feet per second, and this is the position of the truck. The distance between the bike and the end of the truck is 40, and the length of the truck itself is 55. Okay. So the truck has now moved to a new position. Actually, I need to draw this in dotted just to show that this was the previous position of the truck. The truck has now moved to the new position, which is 250 feet ahead. So this is the new position of the truck. How much has the bike travelled in this 25 by 6 seconds? You can find that using the formula S bike is equal to ut plus half at square. So the initial velocity of the bike was 60, time taken is 25 by 6 plus half into acceleration is 6 and time is 25 by 6 the whole square. So you will get this as 302.0833 feet. So the bike has travelled 302 from this position, 302.0833. But first 95 feet, it just has to travel to come neck to neck with the truck, right? So how much distance has it travelled from the truck, from the previous position of the truck? So it will be 302 minus 95, which is 207.0833 feet. So from this position, it has travelled 207, which means that it is somewhere here. This is the new position of the bike, which is 207.0833 feet from the previous position of the truck, and this total is 302.0833. Right? Now the bike has to go 100 feet ahead of the truck, so it wants to reach 100 feet ahead of the truck. How much distance it has to travel further to reach 100 feet ahead? First of all, this much distance will be 250 plus 95. 250 plus 95 minus 302.0833 will give you this distance. So it is how much? 42.9167. 42.9167 the bike has to travel to come just neck to neck with the truck, and then ahead again it has to go 100 feet. So the total relative distance that the bike has to travel with respect to the truck is 142.9167. The reason that I am saying this as a relative distance is because the truck and the bike both are moving, hence it cannot be an absolute distance, but it has to be a relative distance in relation with the truck. So the bike in relation with the truck has to travel 142.9167 feet. To travel this relative distance, the velocity with which it will be traveling will also be a relative velocity. This is a relative distance. The velocity with which the bike travels is also a relative velocity, and that relative velocity will be the velocity of the bike minus velocity of the truck. Because here at this point, when the bike reaches this point, its velocity is 85 feet per second and the velocity of the truck is 60 feet per second. So the relative velocity becomes 85 minus 60, which is 25 feet per second. With this velocity, it is going to travel the relative distance. So how much time is taken? Time taken to travel a relative distance is equal to 142.9167 divided by 25, which is equal to 5.71667 seconds. So this much time is required for the bike to come 100 feet ahead of the truck. Now, again and again I am saying that this is the relative distance. What is the absolute distance that the bike travels? The absolute distance will be the actual velocity of the bike multiplied by this time taken. So the actual velocity of the bike is 85 multiplied by this time will give you the actual distance of the bike. Actual distance travelled from this point. Let me name these points. So let us say that this is your point P, this is point Q, and finally when it reaches here, this is point R. So actual distance travelled between Q and R is equal to 85 into 5.71667, which is 485.9167 feet. Total distance travelled by bike is equal to 302. This much distance it has already travelled, 302.0833 plus 485.9167. So total distance travelled is 788 feet. That's it. So now there are three important points where we need to plot. These points only we need to plot on the graph. The first point is P, the second point is Q, and the third point is R. Only these 3 points we need to plot on the graph. And we are supposed to plot the BT and ST graph for the bike, not for the truck. So only the bike is under consideration. Let us plot these points. Or let me rather tabulate it here. So when t is equal to 0, T, S, B. Okay. When t is 0, let's say S is also 0 and V was 60. This position is basically this one here, point P. At point P, let us say t is 0, this is also equal to 0, but velocity is 60 feet per second. At point Q, how much time is taken from P to Q? The time taken is 25 by 6 seconds. The distance travelled is 302.0833 and the velocity at Q will be 85. So 25 by 6, 302.0833, velocity is 85 feet per second. And at the third point R, further time taken is actually 5.71667. So the total time taken is 25 by 6 plus 5.7167. So 25 by 6 plus 5.7167. Total distance traveled is 788. This one we already calculated. And the velocity does not change now. The velocity remains constant, which is 85 feet per second. If you want, you can also plot the acceleration time. So acceleration at this point, it had a uniform acceleration or a constant acceleration, I would say 6, 6 and then 0, because uh, from this Q to R it is not accelerating anything. So you can also plot the acceleration time graph. Let us plot the graphs now. Okay, so we have time on the x-axis and on the y-axis we have the displacement. First I'll plot the velocity, then I'll plot the displacement. So velocity at time t equals to 0, we have 0, 25 by 6, which is 4.1667, and the final time, this one, is 25 by 6 plus 5.7167, which is 9.8833. So initially the velocity at 0 is 60 and finally it reaches 85. So let us say this is 85 and then it remains constant. So this is our velocity time graph. For displacement time graph, now since the velocity is a degree curve of degree 1, the displacement time graph between these 2 points will be a curve of degree 2. So from 0 it goes to 302.0833 and then 788. From 0 to 4.1667, the curve of displacement time graph will be parabolic, since velocity time graph is a curve of degree 1, which is a straight line, a sloping line. Therefore ST curve will be a parabola, and whether it is an inward parabola or outward parabola, that we will understand by looking at the velocity values at those points. So 60 is less than 85, right? So the slope at point 1 will be less than slope at point 2. So this point and this point, it means that it is an inward parabola. Okay, inward parabola, and then after that we have a straight line till 788. Since this is a curve of degree 0, this is a curve of degree 1, this is curve of degree 2, this is curve of degree 1. So this is your ST and VT graph. You can also draw the AT graph. There is nothing difficult in that. Now let us solve this question. In this, it is given that the boat travels along the straight line with the speed described by this graph. So VS graph is given, velocity displacement graph. We need to construct displacement time graph and acceleration displacement graph. Also, we need to determine the time required for the boat to travel a distance s equals to 400 meters if s equals to 0 when t equals to 0. Fine. So first of all, we can construct the AS graph as we know the formula A is equal to V into dV by ds, and since our velocity is a function of displacement, we can always use this formula. So I'll form the tables here: S, V, dV by ds, and A is equal to V dV by ds. From 0 to 100, our V square is 4s, so V is equal to 2 root s, and dV by ds will be 2 into 1 by 2 root s, which is equal to root s, right? And A is equal to V dV by ds, therefore it will be this root s will get cancelled. A will be equal to 2. Therefore, we see that from 0 to 100, the acceleration is constant. It is 2 meters per second. From 100 to 400, velocity is 0.2 s. So dV by ds is 0.2. Therefore, A will be 0.2 the whole square into s, which is 0.04 times s. At s equals to 100, your acceleration will be equals to 4, and at s equals to 400, your acceleration will be equals to 16, right? 16 meters per second square. So now we have got all the values required. We can easily plot the acceleration displacement graph. Let us plot that. So displacement 0, 100 and 400. Acceleration at this 0 is, from 0 to 100 it is constant. So we have, let me just write 2, 4, 6, 8, 10, 12, 14 and 16. So we know that it is constant from this point to this point, 2, and then at 100 it jumps to 4. Acceleration jumps to 4, and from there it goes to 16. So it's a straight line here. This is your acceleration displacement graph. Further, we need to plot the displacement time graph. So we know that velocity is ds by dt. So we can see that dt is equal to 1 by v into ds. If we integrate both, because since v is in the v is function of displacement, so if we integrate both, so first we have between 0 to 100, for 0 to 100, we have velocity v, which is equal to 2 root s, okay, and the time displacement, okay, displacement is from 0 to 100, but I will keep it as a variable here. Time, let's say it starts from 0, because at this point the time is 0, displacement is also 0. Let time goes to t, so this is dt, and it is starting here from 0 to s, 1 by 2 root s ds. So integration of this will get, this is as t, and integration of this will be half into root s divided by half. So this will be equal to root s. Therefore we get t is equal to root s for first 0 to 100. So at s equals to 0, we have time equals to 0. At s equals to 100, we have time equals to 10 seconds, right? For the next 100 to 400, okay, 100 to 400, it will start from s equals to 100 and let it go till some arbitrary value or some variable value of s, and the time will start from 10 seconds, because see, now we are taking this zone, right, this zone, and here we know that the time is 10 seconds. So from 10 seconds to t, will be the integration limits of time, and from 100 to s will be the integration limits for displacement. So integration of 10 to t dt is equal to integration of 100 to s 1 by v is 0.2 s ds. So this is t minus 10 is equal to, this 1 by 0.2 will be 5, and this is log natural s 100 to s. So this is t is equal to 10 plus 5 of log natural s by 100. This is what we get. This is the time. This is the function of time in the range, in the domain of 100 to 400. So if we plot this, we will get the curve of displacement time. Now this displacement time, the time will be on x-axis and displacement will be on y-axis. 0, 10, and the final value. Let us calculate that final value here. So at s equals to 400, how much is t? T is 16.9315 seconds. So this is 16.9315 seconds. The displacement being 100 and then finally 400. So if you plot this graph, you will get it as a curve like this. You can plot it as I had told you in the calculator. We have that function of table. So if you use table, we can find that for different values of time, we will find what is the respective displacement. So I'll say that time, let time go from, or let displacement go from 0, 50, 100, 150, 200, 250, 300, 350 and 400. And time is, at s equals to 0, time is 0. At s equals to 100, time is 10. At s equals to 50, it will be root 50, which is 5 root 2, or which is basically 7.0711 seconds. Okay. Now ahead of 100, we will use this formula in our calculator in the table function. In the table function, you will have to write it as 10 plus 5 log natural x upon 100. That's it. And you will have to put x starting from 100 and x ends on 400, and the step is 50. So you'll get the values here: 12.027, 13.4657, 14.5815, 15.49, 16.26 and 16.9315. Right? So if you plot this, you will get a curve of something like this. Here we are getting 10, right? It's actually a inward type of curve. Okay, this is not a straight line, it's an inward type of curve that you would be getting for your displacement time curve. So that's it for this lecture. Then take it. Thank you.